Good day everyone, this is your mathematics class with Teacher Camille. Let's have a short review. Match the given set notations to its corresponding Venn diagram below. So look at the shaded part of each Venn diagram. First, we have set A and set B. So the shaded part of this Venn diagram is in the middle of set A and B. So this is the intersection of A and B. Next, we have another set A and set B. So they are both shaded. So this is A union B, or the union of set A and B. Next, the shaded part of this Venn diagram is outside the set A and set B. So we call this as the complement of the union of A and B. Next, the shaded part of this Venn diagram is outside the set B. So this is the A complement, or the complement of set A. All elements outside the set A. Next, the shaded part is only in this region of set A. So this is set A minus set B. Okay, next, let's have letter F. In this Venn diagram, we have set A and set B in the universal set. As you can see, the only part of this Venn diagram that is not shaded is in this part, or in the middle of the set A and set B. So it means this is a complement of the intersection of set A and set B. Next, let's have letter G. In this Venn diagram, this is the only shaded part of this set B. So it means this is the set B minus A, or the difference between set B and set A. Next, we have the set A. All elements in set A. Learning task number 1. List down inside the diagram what is S in each set. First, we have the set of factors of 12. Set A is equal to 1, 2, 3, 4, 6, and 12. Next, set of prime numbers less than 15. So we have set B is equal to 2, 3, 5, 7, 11, and 13. Next, the set of even numbers less than 15. So we have set C is equal to 2, 4, 6, 8, 10, 12, and 14. So this is an illustration of three sets. Now, we will use this three-circled Venn diagram. First, we need to find if there's a common element in these three sets. Now, we have 2 in set A, and also in set B, and we have also in set C. So the common element of these three sets is number 2. So we will put this number 2 on this region. It means the intersection of set A, set B, and set C is 2. Next, let's focus on set A and set B. So is there a common element in set A and B? Yes, we have number 3. So we will put 3 in between set A and set B. Now let's have set B and set C. Is there a common element in B and C? Alright, there is none. Next, we have set A and set C. So their common elements are 4, 6, and 12. So we will put 4, 6, and 12 in this region. Now we will put the remaining elements of these three sets. In set A, we still have 1. So we will put 1 in this region. Next, In set B, we have 5, 7, 11, and 13. So we will put this element in this region. Next, lastly, we have set C. We have 8, 10, and 14. So that's the remaining elements of set C. So we will put that in this region. So this is our final answer. What is Venn diagram? Venn diagram is a diagram that uses circles to represent sets. The relation between the sets is indicated by the arrangement of circles. The Venn diagram is a way of representing sets visually and is named after its inventor, the British mathematician John Venn. Let's have the first example. Use Venn diagram to represent the following sets. So we have the universal set 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Set A is equal to 2, 4, 6, 8, 10. Next, we have set B is equal to 5, 6, 7, 8, and 9. So first, we need to find the common element of these two sets. So we have 6 and 8. We will put that 6 and 8 between the set A and set B. So the intersection of A and B, or the intersection of set A and B, is 6 and 8. Now let's have example number 2. Use Venn diagram to represent sets and the operation of sets. So we have 3 given sets. Set A is equal to 2, 5, 6, 8, and 9. Set B is equal to 1, 3, 7, 9. And set C is equal to 4, 7, 8, 9, and 10. So first, let's find the intersection of set A and set C. So look at the set A and set C. The intersection of these two sets is in this region. So the intersection of set A and set C is equal to 8 and 9. Next, what is the intersection of set B and set C? So let's have set B and set C. So the intersection of these two sets is in this region. So the intersection of set B and set C is equal to 7 and 9. Next, what is the intersection of set A, set B, and set C? So we will use these 3 sets. So the intersection of these 3 sets is in this region. So the intersection of A, B, and C is equal to 9. Next, let's have example number 3. 60 students of grade 7 charity were asked if they have pet animals at home. 40 of the students have dogs and 35 have cats. The questions are, first, how many students have dogs only? Next, how many students own cats only? Lastly, how many students have both pet animals? So let this first set, or this S sub 1, is the set of students with dogs only. Next, this region, this is the set of students with both pets. And in this region, we have the set of students with cats only. Again, S sub 1 is the first region, S sub 2 is the second region, and S sub 3 is the third region. Now, let's find the elements in each region. First, in region 3 or S sub 3. So the number of elements in S sub 1 plus the number of elements in S sub 2 plus the number of elements in S sub 3 is equal to the number of students S, or it is equal to 60. So we will subtract the two equations to find the number of students who have cats only. So 60 minus 40 is 20. So the number of students who have cats only is equal to 20. Next, find the elements in region 1 or S sub 1. So again, let's subtract the two equations to find the number of students who have dogs only. So 60 minus 35, we have 25. So the number of students who have dogs only is equal to 25. Now, find the elements in region S sub 2. Substitute the values of S sub 1 and S sub 3 to find the number of elements in S sub 2. 25 plus the number of elements in S sub 2 plus 20 is equal to 60. The number of elements in S sub 2 is equal to 60 minus 25 minus 20. So we will have 15. So the number of students who have both kinds of pet animals is equal to 50. We have the set of students with dogs only, we have 25. In set of students with both pets, we have 15. In set of students with cats only, we have 20. Let's try this one. The diagram below shows which brand of phone teachers own. S for Samsung, A for Asus, I for iPhone. Number 1 question. How many people owned a Samsung phone? So we have Jill, Bert, Noel, Paula, Ambi, Belle, Che, and Kat. So we have 8. Number 2. How many people owned an Asus phone? We have Kat, Che, Belle, Ambi, and Paul. We have 5. Number 3. How many people owned an iPhone? So we have Belle, Ambi, Paul, Noel, Paula, Banji, and Anna. So we have 7. Next, number 4. How many people owned only Samsung phone? So look at this region. We only have Jill and Bert. So we have 2. Next, number 5. How many people owned only an Asus phone? So there is no element in this region because Kat, Che, Belle, and Ambi owns both Asus and Samsung. And Paul both owned Asus and iPhone. So there is no element or there is no teacher owned only Asus phone. So we have nothing or 0. Next, number 7. What is the union of set S and set A? So we have Jill, Bert, Noel, Paula, Paul, Ambi, Belle, Che, and Kat. Next, what is the intersection of set I and set A? So we have Belle, Ambi, and Paul. Last, what is the difference between I and A, or between set I and set A? So we have Noel, Paula, Banji, and Anne. So that's all for today. Thank you.